Time travel, a scientific exploration. In early 2003, an unusual news story caught public attention. A 44-year-old man named Andrew Carlson was arrested after turning an $800 investment into an unbelievable $350 million in only 2 weeks. When questioned, Carlson claimed he was a visitor from 250 years in the future, who knew exactly which stocks would rise. Authorities dismissed this explanation, but the mystery deepened when investigators found no trace of his existence before 2002. Then, on the day he was supposed to appear in court, he vanished. Although intriguing, the entire story was later revealed to be satire mistakenly reported as fact. Stories like this often lead us to ask a deeper question: is time travel possible, or is it only a fictional idea used in books and films? To understand the reality, we need to explore the scientific concepts behind time travel. The idea of a time machine became popular after H.G. Wells published The Time Machine in 1895. Although fictional, it inspired countless thinkers and creators. Films have since shown various versions of time travel: one-way trips into the future, instant jumps between eras, rewinding time while the traveler remains still, slow reverse travel, and faster than light time reversal. But which of these ideas has scientific grounding? Albert Einstein's theory of relativity introduced the concept of time dilation, the idea that time does not flow at the same rate everywhere. According to Einstein, time behaves like a river, sometimes flowing faster, sometimes slower, depending on speed and gravity. Time can slow down through 2 primary mechanisms: high velocity and intense gravity. 1. Time dilation through speed. When an object moves extremely fast, time for it slows relative to someone who is stationary. This was proven experimentally in 1971 when atomic clocks on airplanes returning to Earth showed slightly less elapsed time than clocks on the ground. Although the effect is tiny at aircraft speeds, it becomes enormous near the speed of light. If a spacecraft could travel at light speed for 10 years, thousands of years might pass on Earth. Astronauts actually experience tiny amounts of time dilation today. Russian cosmonaut Gennady Padalka has effectively time traveled about 0.02 seconds into the future due to time spent orbiting Earth at high velocity. 2. Time dilation through gravity. Gravity also affects time. The stronger the gravitational pull, the slower time passes. Massive objects like planets, stars, and black holes bend the fabric of space-time. Near a black hole, time could slow dramatically compared to regions farther away. This idea was presented scientifically in the film Interstellar. Real-world technology must account for this as well. GPS satellites experience both speed-based and gravity-based time dilation, and their clocks must be corrected constantly. 3. Biological slowing, cryosleep. Another concept often seen in science fiction is cryosleep, the idea of slowing biological aging by cooling the body. While deep freezing remains fictional, NASA is exploring mild hypothermic stasis for astronauts, potentially allowing them to sleep for weeks. Lowering the body's temperature slows chemical reactions and reduces metabolic activity. Rare, real cases of accidental hypothermic survival support the idea that controlled stasis may one day be possible, but all these methods only allow travel into the future. What about traveling into the past? Currently, no technology or physics experiment has demonstrated backward time travel. However, we can observe the past indirectly because light takes time to travel across space. When we observe distant galaxies, we see them as they were millions or billions of years ago. Einstein's equations do not completely rule out backward time travel. Under extreme conditions, space-time might fold in such a way that creates loops, potentially forming wormholes, tunnels connecting 2 distant points in time or space. Physicist Kip Thorne has suggested that microscopic wormholes may constantly appear and vanish at tiny scales. Though far too small to be useful to create a usable wormhole, scientists theorize that negative energy, a form of energy with repulsive gravitational effects, would be required, but currently, we do not know how to produce or sustain such energy in large amounts. Even if wormholes were possible, traveling into the past introduces severe logical problems. The famous grandfather paradox questions how you could exist to travel to the past if your actions there prevent your own birth. Solutions such as the multiverse theory propose that changing the past would create a new timeline instead of altering your original one. Another approach, the predestination model, suggests that events are self-consistent. Anything you attempt to change in the past ultimately causes the very outcome you were trying to avoid. Physicist Stephen Hawking humorously previously tested the idea of time travelers by hosting a party and sending out invitations only after it ended. No one showed up, which he suggested might indicate that backward time travel is impossible. In conclusion, traveling into the future is scientifically possible and already occurs in small amounts. Observing the past is possible through astronomy. Traveling into the past remains theoretical and filled with paradoxes. Time travel, in one form or another, already exists, just not quite as Hollywood imagines it.